What if I told you there's a way to measure the area under this curve easily? Hey, welcome to AI Tutor. Have you ever stared at a weird curve in math class and thought, there has to be a way to figure out how much space is under this thing? Well, buckle up, because today we're diving into the magical world of integration. Trust me, you'll want to stick around for this one. Okay, picture this. You're driving along a curvy mountain road. You're trying to figure out the distance you've traveled, but the road's not straight. It's got all these bends. You can't just multiply the speed by time. So what do? You calculate the total distance by adding up tiny little pieces of the road. That's where integration comes in. It's a method of calculating the area under curves, or finding the total of many small pieces to solve a bigger problem. It's like adding up thousands of tiny puzzle pieces to see the full picture. Cool, right? Imagine you're faced with a complicated problem. You need to find the area under a curve, but it's not a simple rectangle. You can't just use basic geometry. This is where integrals come to the rescue. Let's break it down step by step, shall we? First, we take the area under the curve and split it up into smaller sections. Think of them like strips of small rectangles. The more strips we have, the more accurate the calculation becomes. This is the power of integration. The sum of infinitely many tiny pieces equals the area. This is the essence of what integration does, and it's used everywhere in physics, economics, and of course, artificial intelligence. Now, you might be asking, why does this matter to artificial intelligence and machine learning? Here's the deal. In AI, we use integration to deal with complex problems, like finding the best fit for data or optimizing algorithms. In fact, integration is a key part of deep learning and even predictive analytics. If you're aiming to become an AI pro, understanding integration is not just helpful, it's essential. Yeah, I know, it looks scary at first. Don't worry. You're not the only one thinking, why is math doing this to me? But trust me, once you get the hang of it, you'll be the one laughing all the way to the machine learning bank. Now let's talk about what makes integration so powerful. Beyond calculating areas, it lets us solve problems that involve change and rates of change. Two things we see every day in AI and machine learning models. From calculating gradients in optimization to finding the area under complex functions, integration is like a secret weapon for making smarter algorithms. Now, you might be thinking, this sounds cool, but how do I actually calculate these areas? Well, in the next video, we'll break down the basics of integration and show you how it's done step by step. We'll take a look at definite integrals, indefinite integrals, and some of the coolest techniques used by AI engineers, so make sure you're subscribed and don't miss it. Next up, we'll show you how this theory turns into real-world AI magic. Ready? Let's go. Remember, math is the language of AI, and with integration, you're one step closer to speaking it fluently. Stay tuned, and I'll see you in the next one. Bye!